Okay, this is Math Excel or My Math Up, whatever. It's problem number 9. So suppose you have a simple random sample of size 1,000 obtained from a population whose quantity is 1,500,000 and whose population proportion with a specific characteristic is 0.69. Complete parts A through C below. Okay, so the first question is for us to describe the sampling distribution of p hat. So when they ask us to describe the sampling distribution, anytime they ask you to describe the distribution, they're basically asking, is it normal? Is it bimodal? Is it, there's a bunch of different things we can get into, but primarily in this unit, in chapter 8 and 9, we're looking at, is it normal? And then we're talking about the center, which means the mean, it means the mu, and then we're asking for the spread, which is the standard deviation, because we know that means how fat or how skinny that bell curve is going to be. So how spread out is it going to be is the question. So first of all, is it normal? So when we're talking about it being normal, we know that it has little n, our sample size, which in this case is 1,000, must be less than 5% of big N. So that's 0.05, Miss Benton. So 0.05 times the big N, which is 1,500,000. All right, so 5%, 0.05 times 1,500,000 is 75,000. So we're good there because 1,000 is definitely less than 75,000. Okay, so check. All right, so parameter number 2, or idea number 2, rule number 2 that you have to meet is you have to have n times p times 1 minus p has to be greater than or equal to 10. So little n is 1,000 times p, which in this case is 0.69, times 1 minus 0.69 must be greater than or equal to 10. So let's put that in the calculator. And so that comes out to 213.9, which is also greater than or equal to 10. So we're good there. It is approximately normal. Our mu and our p are the same stinking number, so that would be 0.69. And then we have to calculate our standard deviation. So that's going to be 0.69 times 1 minus 0.69 all over our little n, which is 1,000. And I'm getting mine to come out to be 0.014625. So that would be answer C here. So what is part B? What is the probability of obtaining 710 or more individuals with the characteristic? So the probability that X, or I guess in this case, the probability it's X is greater than or equal to 710. Okay, so here's the trick. Normally we would just do the 710 and we would do 1 times 10 to the 99, and we would do our mean is 0.69 and our standard deviation is 0.014625. But notice what we have going on here, right? If you've got, let's think about this on the bell curve, right? Here's my bell curve, here's my mean is 0.69, and my standard deviation is just 0.014. Okay, and so if you have 710, that's not even on the graph, right? That's way over here. So 710, guys, that is what we're looking for is the proportion, right? It wouldn't even make sense to use the actual number 710. You got to be consistent here in the numbers you're using. So what we want is the p hat, the proportion, 710 over our sample size, which is 1,000. Okay, so that basically when you go to put this in your calculator, instead of putting in 710, make sure you're putting in 0.71 in your calculator. And so I put that in. Everything else is pretty the same. Just make sure that that's a proportion number or a ratio, a percentage, however you want to think of it. instead of the actual value or quantity. So this comes out to be 0.08573. So to 4 decimal places, 0.0857 would be that one. Okay, same thing on part C here. What is the probability of obtaining 600 or fewer? So you're doing the probability that x is less than or equal to 660, but really you're doing the probability that p hat is less than or equal to 660 over 1000 is what you're really doing. And so you're really looking at 0.66 when you go to put this in your calculator. So this is normal CDF, and the only reason we can use normal CDF is because part A worked. It was indeed normal. So we're doing 0.66. Did we change? No, we didn't change our mean or standard deviation because we didn't change our sample size. So our mean is, so this is still, oh, I'm sorry guys, or fewer. This should be -1 times 10 to the 99 is our lower limit. 0.66 is our upper limit. Then our mean is the 0.69, and your standard deviation is the 0.014625. So just, a rule of thumb is always make sure these numbers are in the same ballpark. If you have decimals and then you have some huge number, something's wrong there. So recommend that. So put this in my calculator. 0.66. Everything else is good. And it comes out to approximately 0.020196. So to 4 decimal places, 0.0201.